But I went through and did, it struck me that I wanted to come up with a different example where we can illustrate these notions of indexing and selection examples. And to do that, I use one of the data sets that we have in our sample data set. So remember, we have this sample data set notebook where I talked about all of these sample data sets. Well, the one I'm using right here is the US economic data. And so it's here. So let me just execute my setup. And so I'm using Pandas. I set a file path, and then I basically just read it in using the read CSV function. So I said, okay, so the file path, read my data, and then show the data. And so again, it's a Pandas data frame. I have 4 columns. I have a month column, an unemployment rate column, a jobs added column, and GDP. I then printed those columns in their type. So month is an object type, unemployment rate is a float 64, jobs added is a float 64, and GDP is also a float 64. Okay? So I wanted to come up with an example where we could talk about, or I could demonstrate, and you guys could study, hopefully, this notion of selection and indexing, but with something meaningful, a little bit more expansive than our simple state data. And so what I did is I got this GDP, or I'm sorry, I just got this economic data. And so this is everything from 2008, I think it's January 2008 up until, I don't know, September or August of 2018. So there are a fair number of, well, there are 128. It says it right here. There are 128 rows. And for each one, I have the monthly unemployment rate, the number of jobs added, and the GDP for that month. Okay? You guys familiar with this economic data, just in general, what it is? This is actual U.S., actual reported employment, or actual reported economic data for the United States. Okay? So first thing to notice is we have these NANs. We're going to talk about NAN here in just a little bit and how to deal with NANs, but NAN stands for not a number. And the reason in this data set we have NANs is because GDP is only reported quarterly. So in the financial data, in our financial reporting system, unemployment and jobs are reported every month, but the GDP is only reported every quarter. So here's quarter 1, here's quarter 2, and so there's no report in these two. Okay, so they don't appear in our data set. Okay, everybody with me? Okay, so again, we can extract a column because I have alpha names, month, and it's not a reserved word. I can just use the dot month, or I've commented that I could use the bracket notation. Again, you should make sure you try that and understand that it's going to give you the same thing. Nothing new here. We can also extract multiple columns, as we've seen before. So I'm saying I want the month and the unemployment rate. And so what I don't have is the jobs and the GDP. And so I've just got those 2 columns and the 2 indices. So again, nothing new or spectacular here. I left you a note, things that tend to trip people up. One is the double brackets. I have to have double brackets here. I'm going to get an error saying that you can't extract that way. So now what I did, I asked, sorry, is that a question?
I have a question, yes.
Okay.
Yes, I can see we have a double bracket here. You just mentioned it, but I just want to know why it has to be. Is it because we are actually extracting more than one column, or because we have a list of lists here?
We're extracting more than one column, right? And so when you look at what I did here, so if I extract one, I just have one, right? So this code, this says, give me column month, right? Because we're just extracting one. When I want to extract multiple ones, then I have to pass as a list. And sort of the way to think about that, at least the way I think about it, is when I'm extracting column data, what I expect is my argument is one argument, right? In this case, it's one argument because I only want one column. In this case, it's one argument, but that argument is a list because I want multiple columns. Okay, but it's still one object, right? So you see what I'm saying when I say the argument to the index is one argument.
Yes.
Okay? And this is another one of those things that, as I keep telling you over and over, that you have to practice it. So you have to open up Jupyter, grab a data set, and just start experimenting with it to see these things. Because you can see when I say, look, here's how you do it, and note the double brackets, It's a totally different thing is when I say, hey, show me how you would extract 2 columns, right? That's a totally different experience than understanding exactly when I tell you what it is, you being able to generate it is differently than understanding it. And so to get that experience is where you need to go in and do a little practice. Okay, so I just did, as I said, I wanted to do something that had context rather than just random kind of numbers and indices. And so with economic data, I said, well, suppose that I want the first year of data. I want the first year of data. Well, how can I get it? Okay, well, you know, one way is if I look at the data, I know that index 0 up to index 12 or up to 11 is going to be the first year, right? So if I do that, it's January of 2008 up to December of 2008, right? And so I can just use the index that we see right here, okay? That make sense? You guys see what I'm saying here?
Yes.
So then I have this question for you. So why does the row for index 11 show up? You know, so I've got my slice. My slice is from 0 to 11, 0, 1, 2, 3, blah, 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 down to 11. Why does 11 show up when normally?
Also, you're using the explicit.
Because I'm using the explicit index, exactly right. So I'm using loc here rather than iloc. And just because the index, we defaulted, you know, I didn't specify the index, so I just defaulted. And because I defaulted, it created an index, and that index just happens to match the implicit index. So if I go in and say, hey, do iloc, well, now it doesn't include 11, right? It doesn't include 11 because I use iloc, which is saying use the implicit indexing. If I use loc, then it does include it because I'm using the explicit index, even though the index is, in this case, is the exact same. Okay? Okay, so if we continue, if I say questions like, you know, of interest economically, what month had the highest unemployment rate? I did it in 2 steps. I said, okay, well, let's use the max function on unemployment rate, and then let's use a mask to say, pick out the one that has that. So month, what is this? October of 2009 had an unemployment rate of 10.0. So I did this in 2 steps where I extracted it using the max function, which says take this data frame, this series, and give me the maximum value. And so rate will have the value of 10. And then I masked df1.unemployment rate equal rate. So I said, you know, create a mask that has all falses except for the ones that have value 10, and that's what you got. And then finally I said, hey, let's do this all at once, where instead of that intermediate step of finding the rate, I just incorporated that expression into the mask. Okay? And so this is the type of thing that you would use Pandas for, is you would say, okay, well, I have some data and I'm looking at this and I say to myself, hey, I wonder what month had the highest unemployment rate. You know, and so this is how we would do that. Note also my max function is I can use the max over the entire data frame. So instead of finding the row with the maximum, I'm sorry, just that maximum value, which in this case was 10, I said, okay, well, I'm going to find the maximum value for month, the maximum value for unemployment rate, the maximum value for jobs added, the maximum value for GDP. So it found all of the maxes. So you can think of those as the column maximum values in our data frame. Okay?
Dr. Smith, I have a question.
Okay.
So for here, this max function is from the Pandas, right?
Correct.
Because in our homework 3, we use the max function, but this max function is from the NumPy. So it's different way, right?
Yeah, NumPy has one too, which I'm going to show. I'm going to talk about that here in just a second. So this is different.
Okay.
This is different. Thank you. That's a good question. Okay, so let me continue on through here. I have a couple more minutes, and let me just go through. And this is why I want you guys to go through this notebook, and then hopefully get another one of the data sets that we have and say, ask yourself similar questions. So for example, you know, once I find the maximum unemployment rate, I might say, well, which months had unemployment rate greater than or equal to 9.5? And so again, I use a masking operation and say, let me see those. Let me see those values. And then I left you a note saying, okay, remember what a mask is and how a mask works. And when there's any doubt, check it out. So I go and say, okay, well, here is the mask. This is the mask right here. So using the mask as an index does this filtering operation. Okay, and so one of the videos that I asked you to watch was on Boolean expressions and masking, and I hopefully have said close to 100 times how important this basic idea of masking is, and it's imperative that you understand, what's going on here. So again, I did, okay, well, what about the unemployment rate, job numbers for the year, job added numbers for the year 2010. Once again, I pulled off the month, the unemployment rate and jobs added, because that's all I'm interested in. And then I used the loc function using this index that I know so that I could get the year 2010. So in order to do that, I needed to know what these that the location values are for 2010. And then I did the exact same thing using iloc, which is the implicit indexing function that we see below. And then I did the third version where I used the loc function, and this time I did it within my basic index. So in this one, what I did was I have this part which creates a data frame that includes these 3 columns and all the rows, and then I use this one to extract those rows from the created data set. So this is essentially a 2-part operation. Whereas in this one, I did everything in once. I just said, okay, I want these rows and I want these columns from this data set. Okay? All right, so let me again go a little bit further and talk about these, and this is something I definitely want you to look at, and I will answer questions about these on Thursday. So now I say, what about jobs added for the 12-month period after the month with the maximum unemployment rate? So, I'm looking and I say, well, hey, what happened after we reached maximum unemployment? From the previous query, I know that the max unemployment occurred at loc 21. So now I'm just saying, okay, well, give me the 12 months after maximum employment. Right? That's what I did, is I knew this was loc 21. But if I don't know that, and I want to do this all in one step, here's an application of something called the argmax function. And if you're not familiar with the argmax function, what it says is, give me the argument value for the max, right? So when I said, what's the max unemployment, it gives me that maximum value, 10. If I use argmax, it returns the argument, in this case, the location, of the row that has that maximum value. So you can see in this call, I got everything that I wanted, right? The unemployment numbers and all for the 12 months after without explicitly knowing what that maximum is, because I used the argmax function. Again, something to have a look at. And then lastly, and we're not going to you don't need to focus before Thursday on dealing with missing values, because I will pick up with that on Thursday. But I did want to mention this last part for you to look at, and that's the second call to read CSV. And in this second call, what I did 2 things. First of all, I said, I don't really need this index that matches my implicit index, right? So I want to specifically use the dates as an index. So I can do that or I can try to do that using the parse dates parameter call, and saying that I want index column to be 0. So when I do this one, it doesn't create an index, right? So it didn't create its own index starting with 0 using implicit numbers. It says, hey, he wants to use this one for his index. So what it did was it said, okay, parse these as dates. So instead of being an object, a string object, it's a date time object, and use that date time as the index. And so now when we see, I can do slicing using the implicit with iloc, and I can use the loc using my dates. And so because the date is my index, I can now do things like, okay, if I want to know, between, for 2012, a date range, I can do that directly. I don't have to go back and say, well, what is 2012? What 12 entries? I can just use the dates directly. Okay? That makes sense. And then I can do, there are other ways that I can do slicing and all of that kind of stuff. So go back on your own, take a look at this example. Make sure you have an understanding of what's going on with the slicing and the selection. And as I said, the key to understanding what's going on here is to practice. So don't only look at mine, but go in that data set and find something that's interesting and ask yourself these kinds of questions. And so as a last thing, I know we're out of time here, but let me just leave you with one last comment. This is exactly the kind of thing that I would ask you on a test. I would say, okay, so I want this. Show me how to do this, right? I might say, show me how to get the maximum unemployment rate. And I would expect you to be able to do it. Or I might say, hey, what happens if I do this? No, this one's too complex. I wouldn't ask you that on a test. This one, suppose I say, hey, what does this do? I would expect you to know what that does. Okay, and so the way that you're going to learn that is by going through and experimenting and trying this. And where the meaningful data helps is it lets you ask yourself interesting questions about the data.